Example, if NC4, NC5, NC6 are in AP, find the value of N. Solution. Since NC4, NC5, NC6 are in AP, therefore 2 times of NC5 is equal to sum of first term plus third term, that is NC4 plus NC6. This implies 2 into factorial n divided by n minus 5 factorial into factorial 5 is equal to factorial n divided by n minus factorial 4 into factorial 4 plus factorial n divided by n minus 6 factorial into factorial 6. This implies throughout dividing by factorial n, we will get 2 divided by n minus 5 factorial can be written as n minus 5 into n minus 6 factorial, 1 less than that, into 5 into factorial 4 is equal to 1 divided by n minus 4 into n minus 5 into n minus 6 factorial into factorial 4 plus 1 divided by n minus 6 factorial. Factorial 6 can be written as 6 into 5 into factorial 4. This implies n minus 6 factorial we can cancel throughout, and also factorial 4. Then next step is 2 divided by 5 into n minus 5 is equal to 1 by n minus 4 into n minus 5 plus 1 by 30 implies 2 divided by 5 into n minus 5 is equal to, when you take LCM in the RHS, we get 30 into n minus 4 into n minus 5 in the numerator, 30 plus n minus 4 into n minus 5. This implies by cross multiplication we will get 12, 6 into 12 into n minus 4 is equal to 30 plus n square minus 4n minus 5n, that is minus 9n, minus 4 into minus 5 plus 20. This implies n square minus 9n plus 50 minus 12n plus 12 into 4, 48 is equal to 0. This implies n square minus 21n plus 98 is equal to 0. This implies, what about the factor? 7 plus 14, 21. 7 into 14, 98. Next step is n minus 7 into n minus 14 is equal to 0. This implies n is equal to 7 or n is equal to 14. Example, find the number of diagonals that can be drawn by joining angular points of octagon. Solution. Since number of diagonals of a polygon of n sides is equal to NC2. Selecting 2 points to get a line segment from n points, minus, but all line segments will not become diagonals, so we should subtract number of sides. Therefore, number of diagonals of an octagon is equal to 8C2 minus 8 is equal to 8 into 7 divided by 2 into 1 minus 8 is equal to 28 minus 8 is equal to 20. Note, number 1, number of straight lines that can be drawn from n points of which p points are collinear, means they are on the same line, is equal to NC2 minus PC2 plus 1. Second one, number of triangles can be formed from n points of which p points are collinear, is equal to NC3 minus PC3. Example, out of 10 points in a plane, 6 are in a straight line. Find the number of triangles formed by joining these points. Solution. Required number of triangles is equal to 10C3 minus 6C3 is equal to 10 into 9 into 8 divided by 3 into 2 into 1 minus 6 into 5 into 4 divided by 3 into 2 into 1 is equal to 120 minus 20 is equal to 100. Binomial theorem for any positive integer n. A plus b whole raised to the power n is equal to nc0 a raised to the power n plus nc1 into a raised to the power n minus 1 into b plus nc2 into a raised to the power n minus 2 into b square plus dash 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 plus nc n minus 1 into a into b raised to the power n minus 1 plus ncn into b raised to the power n. Proof. This theorem we can prove by mathematical induction. Let P of n be a plus b whole raised to the power n is equal to nc0 a raised to the power n plus nc1 to a raised to the power n minus 1 into p plus nc2 a raised to the power n minus 2 into p square plus dash 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 plus nc n minus 1 into a into b raised to the power n minus 1 plus ncn into b raised to the power n. For n is equal to 1, LHS of 1 is equal to a plus b whole raised to the power 1 is equal to a plus b. And RHS of 1 is equal to 1C0 into a raised to the power 1 plus 1C1 into a raised to the power 1 minus 1 into b. For the next terms, we cannot take n less than 2. So, 1C0 is equal to 1 into a means we will get a. 1C1 is equal to 1. A raised power 0 is 1 into b means plus b will get. LHS of 1 is equal to RHS of 1. Therefore, P of 1 is true. Let us assume that P of n is true for n is equal to k. Therefore, P of k is a plus b whole raised to the power k is equal to kc0 into a raised to the power k plus kc1 into a raised to the power k minus 1 into b plus kc2 into a raised to the power k minus 2 into b square plus dash 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 plus k minus 1 into a into b raised to the power k minus 1 plus kck into b raised to the power k. For n is equal to k plus 1, a plus b whole raised to the power k plus 1 is equal to a plus b into a plus b whole raised to the power k according to the laws of exponents is equal to a plus b into a plus b whole raised to the power k, that is kc0 e raised to the power k plus kc1 e raised to the power k minus 1 into b plus kc2 e raised to the power k minus 2 into b square plus dash 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 plus kc k minus 1 into a into b raised to the power k minus 1 plus kck into b raised to the power k is equal to, when you multiply all the terms of second bracket by a, we will get kc0 into a raised to the power k plus 1 plus kc1 into a raised to the power k minus 1 plus 1, that is k into b plus kc2 a raised to the power k minus 1 into b square plus dash 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 plus k minus 1 into a square a into a b raised to the power k minus 1 plus kck into a into b raised to the power k. By multiplying all the terms of second bracket by b, we get plus kc0 a raised to the power k into b plus kc1 a raised to the power k minus 1 into b square plus dash 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 plus kc k a square b raised to the power k minus 1 plus kc k minus 1 a into b raised to the power k plus kck b raised to the power k plus 1. this is equal to kc0 into a raised to the power k plus 1 plus, from these two terms we can take a raised to the power k into p common, then we will get kc1 plus kc0 into a raised to the power k into p plus, similarly from these two terms we can take a raised to the power k minus 1 b square common, then kc2 plus kc1 into a raised to the power k minus 1 b square plus dash 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 plus kck plus kck minus 1 into a into b raised to the power k plus kck into b raised to the power k plus 1. Is equal to kc0 is equal to 1, and also k plus 1 c0 is equal to 1. Therefore, in place of kc0 we can write k plus 1 c0 into a raised to the power k plus 1 as it is, plus kc1 plus kc0. We have learned ncr plus ncr minus 1 is equal to n plus 1 cr. According to that, we can write k plus 1 c1 a raised to the power k into p plus k plus 1 c2 a raised to the power k minus 1 b square plus dash 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 plus k plus 1 ck into a into b raised to the power k plus, since kck is equal to 1, also k plus 1 ck plus 1 is equal to 1. Therefore, we can replace kck by k plus 1 c k plus 1 into b raised to the power k plus 1 we can write as it is. So now we have got the result in terms of k plus 1. So p of k plus 1 is true whenever p of k is true. Hence, p of n is true for all n belongs to n.